Alright, so today's notes is polynomial operations, multiplication, and this page is part 1, and we have our steps. Step 1 is to multiply each term by every term in the other set of parentheses. And that's the significant part, is that every term needs to be multiplied by every other term in the other set of parentheses. So when you multiply a term, you need to make sure that you multiply the coefficients, and remember the coefficients are the numbers in front of the variables, and then you need to add the exponents. So those two pieces need to happen whenever you multiply the terms together. Step 2 is to combine like terms. And then step 3 is to put it in standard form, if it's not already in standard form. So that one's a if needed. So let's go ahead and look at form 1. And so this is one way that you can go about to multiply. So you're given the said example of our binomial and our trinomial, and we're going to multiply each term by every term in the other set of parentheses. So the first, you can see that we're doing just that. The 2x is being multiplied by every single term in this other set of parentheses, and the 3 is being multiplied by every other term in this set of parentheses. So what we get is that when we multiply by our 2x, and that when we multiply by our 3. So when you set these up, you can notice that you can already start aligning them to be able to do step 2, which is add them together. And in this situation, it already allows for step 3, which is in standard form. Right? So that is the first way, and a very common way to be able to multiply polynomials. And even if this was a trinomial or anything like that, you just keep doing the same process with each term in one parentheses to each term in the other parentheses. Okay, so let's scoot this up. Okay, so let's look at form 2. So first you'll multiply the group by each term in the other parentheses. So second, you'll basically repeat what's in form 1, you'll multiply each term, and then combine like terms and put in standard form. So this example, instead of doing the individuals by each individuals in here, you are instead taking the entire group of one parentheses and basically distributing it or multiplying it to then each term in the other set of parentheses. An important thing to note is that this is basically what's called factoring by grouping. It's a form of it. It's the reverse of it, you could say. So this is again part of that multiplication and division are the same thing, and it's a great step to learn for things that might come up later on in the class. So we take our entire group and I multiply it by 2x, and my entire group and multiply it by, in this case, positive 3. So I have a plus 3 because it's a positive 3. And you'll see that they are being multiplied by the entire group. And then basically from there, we repeat the steps from above. Step 1, multiply each term by every term in the parentheses. Over here, the same thing. So we get that. and that. We then combine like terms and make sure it's in standard form. Okay, so let's go ahead and look at form 3, and this one's a more fundamental form, but not used very often except for initial explanation. So basically you stack them and then you solve them like normal multiplication. So what you'll see over here is kind of like if I had 1, 1, so this is kind of like my 10s and my 1s, so that gives me 11. 2 10s and 3 gives me 23. So just like if this was the number, I'd do 3 times 1, 3 times 1. I'd have my placeholder, 2 times 1, 2 times 1, and then add and combine. And over here you'll notice the same thing, that I can stack them, I can multiply basically with this having a 1 in front of it. Scoot over, because again we're now in the next place value. 2x times 1, 2x times 10, or 2x times x, and then combine like terms like our normal basic forms. Okay, and for our basic step 1, step 2. Okay, and so let's go on to form 3, or excuse me, form 4. Okay, so we have form 4, and this one actually is going to be the closest connector that you're going to practice between multiplication and division. And so if you know, like 3 times 4 is 12, 12 divided by 4 is 3. So that kind of concept of being able to go forward and backwards between multiplication and division stands true even with polynomial operations of multiplication. So this next form here is going to be helping to set you up to practice division of polynomials. So we have our example, and as you notice, it's kind of set up in that division box already. But we're going to be multiplying, because that's all it is this number times this up here usually gives you what's down here. So here's our example problem. And rewrote it so you can kind of see the steps. So step 1 is you're going to take 2x and times it by 3x, or 3x times 2x, and that gives you 6x. The second step is going to be take 2x and times it by 4. That gives you 8x, and boom, you're finished. And this also goes forward and backwards for our division. If I have 6x plus 4x, oops, and this should be squared, divided by 2x, my answer would be 3x plus 4, because 2x times 3x gives me 6x squared, 2x times 4 gives me 8x. So you can start seeing how multiplication and division are related. So let's come down to our next example. So here we had our initial setup, and we're multiplying this factor and this factor. And so first I'm going to take 3x squared and multiply it by my x plus 1. And then I'm going to take my 2x and multiply it by my x plus 1. And if you notice, I'm shifting it over to line it up. Okay. And then this is the same thing as the group multiplication. So this entire group times -4. And I kind of shifted it over just to keep it all lined up. And then I'm going to do the same steps. Now that I've multiplied each term by the group, I'm going to combine like terms and add them up. So this here is your product after multiplying these two polynomials together. And at the same time, if I was to have this product here divided by this binomial, that would be my answer. Okay. So each one of these times this gave me these here. And we'll get more into this when we actually go into the division. So a note to remember is just our place values, because this especially comes up later on again when you do division, but it's good to remember with multiplication as well, that if I have 3x to the fourth minus 1, that means I have 0x to the thirds, 0x squared, and 0 x's. And this is technically what this polynomial should look like, but it's just been simplified and rewritten in its simplest form. Alright, I hope this helped.